What if everything we think we know about the origins of the universe is just a fragment of a much larger story, one that stretches far beyond the boundaries of time itself? Picture this: entire civilizations, advanced beyond our wildest imaginations, possibly thriving in the cosmic darkness long before the Big Bang even ignited the first sparks of creation. It sounds like science fiction, but what if it's not? Across the globe, ancient texts and unexplained artifacts hint at knowledge that shouldn't have existed: blueprints for technology, astronomical precision, and myths that echo with eerie familiarity. Could these be the faint echoes of civilizations lost to time, cultures so ancient they predate the very fabric of our universe? This isn't just about rewriting history books, it's about unraveling the deepest enigma of existence. What if the universe cycles through endless births and deaths, each one leaving behind traces of what came before? Some of the brightest minds in astrophysics and archaeology are now daring to ask these questions, piecing together clues that challenge everything we thought we knew. From the possibility of higher dimensional beings to relics hidden in plain sight, the theories we're about to explore will stretch your perception of reality itself. Today, we're embarking on a journey through 30 of the most astonishing theories about the universe's first civilizations, ideas that blur the line between myth and science, between the impossible and the undeniable. We'll dive into cosmic archaeology, examine whispers of lost technologies, and confront the haunting question: are we alone, or are we simply the next chapter in a story that began billions of years ago? Strap in, this is more than a video. It's a detective story written in the stars, and you're about to become part of the investigation. The answers might just change how you see everything. Imagine for a moment a civilization so advanced that their technology didn't just surpass ours, it transcended the very laws of physics as we understand them. This is the spine-tingling premise of the Precursor Civilization theory, the idea that beings of unimaginable intellect might have thrived in the universe's earliest moments, shaping reality itself. We're not talking about mere aliens with flying saucers. This is something far grander. Picture a culture that didn't build cities or machines, but instead manipulated the fabric of space-time, tweaking quantum fields like a composer tuning the notes of creation. Their tools wouldn't be made of metal or code, but of dark matter strands woven into the cosmos, their presence hidden in plain sight. One of the most tantalizing clues lies in the cosmic microwave background, that faint glow left over from the Big Bang. Scientists have long studied its subtle imperfections, the tiny temperature variations that hint at the universe's infancy. But what if some of those patterns aren't random at all? A handful of physicists have dared to suggest that certain anomalies, unexplained alignments, or geometric quirks in the radiation could be signatures of deliberate engineering. Imagine finding the fingerprints of an architect in the blueprint of reality itself. It's as if we're staring at a cave painting, only to realize it's actually a schematic for a quantum computer. The implications are staggering. If such beings existed, their technology wouldn't just be advanced, it would be indistinguishable from nature. A black hole might not just be a cosmic vacuum cleaner, but a power source or supercomputer. Dark energy, that mysterious force accelerating the universe's expansion, could be the residual energy of their experiments. Even time might not be what we think it is. Some theorists speculate that these precursors could have manipulated causality, leaving behind paradoxes in particle physics that we're only now beginning to notice. And then there's the haunting question: where are they now? Did they ascend to higher dimensions, leaving behind artifacts encoded in the laws of physics? Or did they unravel the universe's secrets so completely that they became something beyond civilization as we know it? The terrifying yet thrilling possibility is that we're surrounded by their legacy every second, mistaking their grand design for mere cosmic coincidence. As we peer deeper into the quantum foam or map the large-scale structure of the cosmos, we might not just be exploring the universe, we could be reading their memoirs written in the language of gravity and light. Now consider this bizarre twist in the cosmic puzzle. What if the first civilization wasn't a society of beings at all, but a single floating mind spontaneously born from the chaos of the early universe? This is the unsettling premise of the Boltzmann Brain Paradox, a thought experiment that turns our understanding of consciousness and existence inside out. The idea stems from thermodynamics, the study of energy and randomness. In an infinitely old universe, particles bouncing around at random could theoretically arrange themselves purely by chance into a fully formed, self-aware brain. Not attached to a body, not born from evolution, but conjured into existence by the sheer statistical fluke of atomic collisions. That brain might experience an entire lifetime's worth of thoughts and memories in an instant, convinced it's lived in a real world when in reality, it's just a fleeting accident of entropy. But here's where it gets truly mind-bending. Some theorists take this further, suggesting that our entire universe might not be the product of a Big Bang, but the hallucination of one of these primordial Boltzmann brains. Every star, every planet, even your own sense of self, could all be the elaborate daydream of a disembodied consciousness flickering into existence in the void. It's as if reality is a soap bubble formed on the surface of an infinite ocean of chaos, destined to pop the moment the universe notices its own absurdity. This theory dovetails eerily with modern simulations hypotheses. If a Boltzmann brain can fabricate an entire reality within its fleeting existence, how can we be certain we're not the same? Ancient Hindu texts spoke of the universe as the dream of Brahman, while cutting-edge quantum physicists debate whether observation itself might create reality. The common thread is spine-chilling. Consciousness might not be a byproduct of the universe, but the very thing holding it together. Of course, most scientists dismiss Boltzmann brains as a statistical absurdity, but that's exactly what makes them so fascinating. Their possibility forces us to grapple with the deepest questions. What makes reality real? Could the universe's first thinkers have been these phantom minds, their brief flashes of awareness seeding the cosmos with strange pockets of order? Maybe we're not the heirs of an ancient alien civilization, but the unlikely descendants of a quantum daydream that forgot to fade away. What if the universe itself is a vast archaeological dig, hiding the ruins of civilizations so ancient they predate not just humanity but time as we know it? Among the most spine-chilling theories is the idea of quantum archaeologists, beings who mastered the art of etching their legacy into the very fabric of reality, leaving messages not in stone or metal, but in the immutable laws of physics. Think about the fundamental constants of our universe: the speed of light, the strength of gravity, the charge of an electron. These values seem fixed, arbitrary, yet they're the precise reason stars burn and atoms bond. But what if they're not accidents at all? Some physicists speculate that these numbers could be deliberate, like cosmic hieroglyphs left behind by a civilization that transcended physical existence. Like finding a signature woven into the threads of spacetime itself, the most tantalizing hiding spots for these artifacts, quantum fluctuations, those tiny, unpredictable vibrations in empty space. At scales smaller than atoms, particles blink in and out of existence, creating a froth of potential energy. If an ultra-advanced civilization wanted to stash a message for future universes, this chaos might be the perfect vault. Imagine etching data into the spin of virtual particles, ensuring it resurfaces again and again across endless cosmic cycles. Black holes offer another eerie possibility. At their singularities, the laws of physics break down, time stops, matter compresses into infinity. Some theorists suggest these cosmic abysses could be more than destructive forces; they might be libraries. A civilization that mastered quantum gravity could have engineered black holes as time capsules, encoding information in their event horizons. the data wouldn't just survive the death of a universe, it would be stretched, warped, but never erased. It's like writing a message on the edge of a whirlpool, knowing the water will distort it but never truly wash it away. And then there's the faintest clue of all the so-called impossible particles. Certain anomalies in quantum experiments, like electrons behaving as if they remember past interactions, or entangled particles communicating faster than light, might not be glitches. They could be echoes, like finding scratches on a diamond that suggest it was once part of a grander jewel. These quantum quirks might hint at a deeper layer of engineering beneath reality's surface. The haunting beauty of this theory is its elegance. If true, we wouldn't need to dig up ancient cities or decode alien radio signals. The evidence would be all around us in the weight of a proton, the glow of distant quasars, even the way light bends around empty space. Every time a physicist measures a fundamental constant, they might not just be uncovering nature's rules. They could be reading a letter from the architects of existence itself, written in the only language eternal enough to survive the death and rebirth of universes. The ultimate time capsule isn't buried in the ground. It's written into the bones of reality. There's a shadow universe woven into the fabric of ours, invisible yet exerting its gravity on everything we see. And within that darkness, some researchers suspect entire civilizations may have risen and fallen without us ever noticing. This is the spine-tingling premise of the dark matter architect's theory. The idea that the universe's first builders weren't made of atoms, but of the mysterious substance that outnumbers ordinary matter 5 to 1. Picture this, a species that doesn't reflect or emit light, whose cities aren't clusters of metal and glass, but intricate knots of gravitational pull. Their technology wouldn't rely on electromagnetism like ours, but on manipulating the invisible scaffolding that holds galaxies together. Imagine dark matter filaments, those vast, thread-like structures stretching across the cosmos, not as accidental cosmic cobwebs, but as intentional superhighways or communication networks for beings whose very biology is woven into the universe's hidden architecture. The clues might already be in front of us. Astronomers mapping the large-scale structure of the universe keep finding anomalies, places where galaxies cluster in patterns that defy standard models of cosmic evolution. Some of these peculiar formations, like the inexplicably vast Einstein ring, gravitational lenses, or the bizarrely empty Boots void, could be more than cosmic oddities. They might be the ruins of dark matter engineering projects, gravitational imprints left by civilizations that shaped the cosmos the way we shape clay. Even more intriguing is the role dark matter may have played in the universe's infancy. The first billion years after the Big Bang were a chaotic dance of matter and energy, with ordinary atoms too hot and scattered to form stable structures. But dark matter, unaffected by the searing radiation, could have clumped together far earlier. If intelligence emerged there, those beings wouldn't just have had a head start, they'd have had the power to sculpt the universe's destiny. Their gravitational nudges might have steered the formation of the first stars, determining where and when galaxies could ignite. But here's the most haunting possibility of all: what if they're still here? Dark matter doesn't just pass through our world unseen. It passes through us, billions of particles streaming through your body every second. A dark matter civilization could be watching us right now, their perception of reality so alien that they don't even register our existence any more than we notice the bacteria in a drop of water. Their monuments wouldn't be pyramids or satellites, but the very distribution of galaxies, their history written not in books but in the gravitational ripples echoing across 13.8 billion years. The next time you look up at the night sky, remember, you're not just seeing stars. You might be gazing at the ghostly fingerprints of architects who built with gravity itself, their legacy hidden in plain sight, etched into the darkness between the light. Long before atoms cooled into existence, the universe was a seething ocean of plasma, a superheated soup of charged particles crackling with energy. In this primordial inferno, where temperatures exceeded millions of degrees, conventional life as we know it would be impossible. But what if life didn't need planets, water, or even molecules to emerge? Enter the radical theory of plasma-based lifeforms, intelligences born not in the calm of cosmic evolution, but in the violent throes of creation itself. Picture a being not made of flesh and bone, but of swirling magnetic fields and currents, its body a self-sustaining vortex within the cosmic storm. In the early universe, plasma wasn't just chaos, it was a canvas. Vast filaments of ionized gas stretched across the cosmos, forming natural circuits where energy could flow. Some researchers speculate these filaments might have acted like neural networks, allowing complex patterns to emerge. A plasma lifeform wouldn't think with neurons, but with twists and knots in magnetic fields, processing information in the flicker of particle collisions. Their technology, perhaps they sculpted cosmic strings, hypothetical, thread-like defects in space-time, into tools, using them to transfer energy or even send messages across the newborn universe. Detection is the greatest challenge. After the universe cooled, atoms formed, and plasma faded into the background. Any remnants of these beings would have dissolved like whispers in the wind. But there are tantalizing hints, strange anomalies in the cosmic microwave background, unexplained swirls and arcs, could be the fossilized imprints of their structures. Even today, plasmoids, self-organizing balls of magnetized plasma, exhibit lifelike behaviors in labs, sustaining themselves far longer than physics predicts. Could these be echoes of a forgotten form of existence? The most haunting possibility, we might be their descendants. Some theories suggest plasma life could have encoded information into quantum fluctuations, seeding the universe with blueprints for later intelligence. Every star that ignites, every galaxy that spins, might carry fragments of their legacy, not as ruins, but as living instructions written into the fabric of reality. If true, we aren't just searching for lost civilizations. We might be piecing together the story of our own cosmic ancestry, written in the language of fire and light. The most dizzying possibility of all isn't just that ancient civilizations existed, but that they might have built the very universe we now call home. This is the shocking premise of the time loop founders' theory, where the architects of reality aren't just lost to history but woven into its birth. Imagine a species so advanced they didn't just manipulate time, they became the reason time exists at all, engineering the Big Bang in a paradox where they are both creators and creations. At the heart of this theory lies a concept from modern physics called closed time-like curves, hypothetical pathways where time bends back on itself. If an advanced civilization mastered these curves, they could effectively send information or even physical objects into their own past. Now stretch that idea to its absolute limit. What if they didn't just send a message but orchestrated the first moment of existence? Picture a civilization on the brink of cosmic transcendence, triggering a new Big Bang to ensure their own evolution, their fingerprints left in the fundamental constants that allow stars and planets, and eventually themselves, to form. It's like a painter who steps into their own canvas, becoming both the artist and the artwork in an endless loop of creation. The math isn't as far-fetched as it sounds. Quantum gravity models suggest the Big Bang might not have been a true beginning, but a bounce from a previous universe's collapse. If remnants of that prior cosmos survived, whether as data, energy patterns, or even consciousness, they could have seeded the conditions for their own rebirth. Some versions of string theory propose that universes can be artificially spawned in labs, like bubbles forming in a quantum foam. A civilization reaching this pinnacle wouldn't just witness the birth of a new universe, they'd be its midwives, carefully tuning the laws of physics to guarantee their eventual return. But how would we even look for evidence of such a loop? The answer might lie in the eerie precision of our universe's design. The cosmological constant, the value determining how fast space expands, is fine-tuned to an absurd degree. Alter it by a hair and stars couldn't form. Some physicists argue this isn't luck but proof of cosmological natural selection, where universes capable of spawning life are the ones that multiply. The time loop founder's theory takes this further. That tuning isn't random but deliberate, like finding a message in a bottle that reads, "Throw this bottle into the sea again." The laws of physics might be instructions for perpetuating the cycle. The most haunting implication: if this theory holds, we might not just be searching for the universe's first civilization. We could be living inside their ultimate experiment, destined to one day repeat the act ourselves. The very atoms in your body might carry the echo of a choice made by your descendants across the loop of time, a paradox written into the stars. Every equation we solve, every particle we collide, might not just be science, but archaeology, uncovering the blueprint of a reality built intentionally to birth its own builders. The universe's greatest mystery might not be where we came from, but whether we're destined to become the architects of our own origin. Black holes aren't just cosmic vacuum cleaners. They might be the universe's most sophisticated hard drives, and some theorists suggest we've been staring at ancient data storage all along. The black hole engineer's hypothesis dares to ask, what if primordial black holes, those mysterious remnants from the universe's first moments, were deliberately crafted as quantum time capsules by civilizations that existed before the first stars even flickered to life? Picture a black hole not as a destructive force but as a perfect vault. At its event horizon, time slows to a crawl. From an outsider's perspective, matter never truly crosses over but lingers, stretched into an infinite smear of quantum information. Now imagine engineering these objects on a microscopic scale, seeding them with encoded data designed to survive the heat death of the cosmos itself. A civilization mastering this wouldn't need pyramids or stone tablets. Their history could be written in the spin of singularity, waiting to be decoded by whoever or whatever comes next. Here's how it might work. In the universe's earliest seconds, chaotic fluctuations in density could have birthed countless tiny black holes, some no heavier than a mountain yet packing the density of a star. Unlike their massive cousins, these primordial black holes wouldn't evaporate quickly. They'd persist, whispering their secrets across eons. Advanced beings could have manipulated quantum fields to create these objects intentionally, imprinting data onto their Hawking radiation like cosmic Morse code. Every particle emitted wouldn't just be random noise. It could be a pixel in an interstellar message spanning billions of years. Even more mind-bending is the idea of black holes as quantum computers. The frenzied dance of particles near the event horizon, a phenomenon called holographic information scrambling, might not be chaos but computation. Some physicists argue that black holes could perform calculations at speeds impossible for ordinary matter, solving equations by exploiting the warping of spacetime itself. An ancient civilization might have used these primordial black holes as processors, encoding complex simulations or even entire consciousnesses into their gravitational whirlpools. The echoes of those operations could still reverberate today, hidden in the subtle patterns of radiation leaking from distant black holes across the cosmos. So where's the proof? Some researchers are hunting for anomalous Hawking radiation, particle emissions from black holes that don't match standard models. Others study gravitational waves, listening for the ringing of ancient black holes that might carry unnatural harmonics, the most tantalizing clue. Certain microscopic black holes predicted by string theory could function like Rosetta Stones, their quantum states preserving information in ways our physics is only beginning to grasp. The chilling implication is this: if the theory holds, we might not need to search distant planets for alien ruins. The greatest archaeological site in existence could be floating right in front of us, cloaked in darkness, humming with trapped knowledge, waiting for the day we learn to read gravity itself like an open book. Every black hole in the sky might not be a tomb but a library, its shelves carved from bent spacetime and its text written in the language of singularities. Imagine threading a needle through the fabric of reality itself. That's the mind-bending possibility behind the cosmic string weaver's theory. These hypothetical filaments, thinner than an atom yet denser than a neutron star, are thought to be cracks in space-time left over from the universe's violent birth. But what if they weren't just random defects? What if they were tools carved and harnessed by civilizations so advanced they saw the cosmos not as a fixed stage, but as raw material to sculpt? Cosmic strings are like the universe's scars, one-dimensional flaws where the very rules of physics twist. Under enough tension, a single inch of string could outweigh Mount Everest. Yet their true power lies in their gravitational influence. A string moving through space would warp light behind it like a lens, creating double images of distant galaxies. An advanced civilization could have arranged these strings into vast webs, using their gravitational pull to channel energy across interstellar distances or even manipulate time itself. Picture a network of these ultra-thin threads stretching between stars, not carrying electricity like our power lines, but bending space-time to transmit information or energy instantly, no speed of light delay. The most tantalizing clue are unexplained gravitational lensing events. Astronomers occasionally spot distant objects distorted in ways that don't match known galaxy formations. Some of these anomalies could be the ghostly imprints of ancient string networks, their gravitational fingerprints lingering long after their builders vanished. Even stranger are the rare cases where light seems to split into perfectly symmetrical duplicates, as if passing through an invisible slit in reality. Could these be the frayed edges of a cosmic loom once woven by intelligence? And then there's the energy potential. Quantum theory suggests plucking a cosmic string could release bursts of energy rivaling supernova. A civilization mastering this wouldn't need stars for power. They could strum these filaments like guitar strings, harvesting vibrations from the fabric of spacetime itself. The echoes might still resonate today, hidden in the cosmic microwave background as faint, rhythmic pulses, like finding the fossilized vibrations of a billion-year-old instrument. The chilling beauty of this theory is its elegance. Unlike physical ruins, cosmic strings wouldn't erode. They'd persist, drifting through eternity as both artifacts and active mechanisms. Every time a physicist calculates their properties or an astronomer spots an unexplained warp in starlight, we might not just be studying abstract physics, we could be reverse engineering the infrastructure of a civilization that turned the universe into their workshop, their fingerprints forever pressed into the wrinkles of spacetime. What if civilizations didn't just survive the Big Bang but thrived during it, riding the universe's explosive expansion like cosmic surfers? The inflationary era settlers theory proposes something even more radical, that intelligence could have emerged in the first incomprehensible fraction of a second after creation, when space itself was stretching faster than light. This wasn't just a hostile environment, it was reality tearing itself apart at the seams, temperatures so extreme that matter couldn't even form. Yet some theorists argue these impossible conditions might have been the perfect crucible for a form of life we can barely imagine. Picture existence in those first moments, a superheated quantum foam where the very concept of place had no meaning, as new space was generated faster than information could cross it. Any civilization arising here wouldn't be bound by stars or planets. Their habitat would be the vacuum itself, their bodies composed of fluctuating energy fields rather than atoms. Like spiders weaving webs from the fabric of spacetime, they might have built structures not in space but of space, manipulating inflationary expansion to create self-sustaining pockets of order within the chaos. The real marvel is how they could have survived the end of inflation, when the universe's breakneck expansion suddenly slowed. Most models suggest this transition would have been catastrophic, a cosmic reboot erasing all complexity. But here's the genius twist. These beings might have encoded their essence into vacuum fluctuations, those quantum jitters that persist even in empty space. Imagine compressing your entire civilization's knowledge into the spin of virtual particles, like engraving an entire library on the surface of a single electron. When inflation ended and matter finally condensed, those subtle quantum imprints could have slowly unfolded, seeding later universes, including ours, with fragments of their legacy. Evidence might be hiding in plain sight. Certain anomalies in the cosmic microwave background, especially odd spiral patterns observed in Planck satellite data, look suspiciously like information encoded in polarization. Some physicists speculate these could be artifacts of deliberate manipulation during inflation, like finding fingerprints in the primordial fireball. Even stranger are relic quantum fields that seem too perfectly tuned, as if someone adjusted the universe's initial settings to allow complexity to emerge. The most profound implication: we might be their unwitting heirs. The same quantum processes allowing atoms to form and stars to ignite could have been pre-programmed by these ancient architects, their designs unfolding across billions of years. Every time a physicist measures a fundamental constant or detects a quantum fluctuation, they might not just be studying nature, they could be deciphering a message scrawled into existence by the universe's first thinkers, written not in stone or light, but in the very rules of reality itself. In the violent dawn of the universe, matter wasn't alone. It had a sinister twin, an equal and opposite shadow known as antimatter. For every particle created, there should have been its mirror image, identical in every way except for one lethal difference: their charges were flipped. When matter and antimatter meet, they annihilate in a burst of pure energy, leaving nothing behind. Yet today, our universe is overwhelmingly made of matter, with antimatter vanishingly rare, just one particle for every billion ordinary ones. This cosmic imbalance has haunted physicists for decades, but what if that missing antimatter didn't just vanish? What if it hosted civilizations that flourished, built, and ultimately perished in the ultimate cosmic war? The mathematics is chillingly elegant. In the first moments after the Big Bang, matter and antimatter should have existed in perfect balance, equal parts creation and anti-creation. Had this symmetry held, the universe would have annihilated itself into oblivion in a flash of gamma rays, but something tipped the scales. Most antimatter vanished while matter endured. The standard explanation points to quantum fluctuations favoring matter by a hair, but some theorists propose an even wilder possibility: that antimatter didn't just disappear. It formed structures, galaxies, even intelligent life, only to be erased in collisions with our matter-dominated reality. Think about what an antimatter civilization might look like. Their chemistry would mirror ours, with positrons orbiting antiprotons in anti-atoms. Their stars would burn just as bright, their planets just as solid, until they encountered even a speck of our matter. A single gram of anti-hydrogen meeting ordinary hydrogen would release the energy of 43,000 tons of TNT. This means their greatest existential threat wouldn't be asteroids or supernova, but the very fabric of space around them, contaminated with traces of drifting matter. Their architecture might have been designed to detect and deflect these lethal intruders, their cities shielded behind magnetic fields powerful enough to repel stray atoms like cosmic bulletproof glass. The most haunting evidence might be hiding in plain sight. Gamma-ray bursts, some of the most energetic events in the universe, often defy explanation. While many come from collapsing stars or black hole mergers, a handful exhibit strange signatures, as if vast reservoirs of antimatter suddenly encountered matter and ignited. Could these be the final screams of anti-civilizations, their megastructures annihilating in catastrophic chain reactions? Even more tantalizing are the so-called empty regions of space where matter seems suspiciously sparse, not just voids, but places where something appears to have scoured the area clean. If antimatter galaxies once thrived, their obliteration would leave behind ghostly bubbles in the cosmos, their absence detectable only by what isn't there. This theory forces us to confront a disturbing truth. the universe may not just be indifferent to life, but actively hostile to half of it. Every star we see, every planet we walk on, exists only because our ancestors in the cosmic war won by the slimmest margin. The eerie silence of the cosmos might not mean we're alone, just that the other half of creation was erased before it could speak. As we peer deeper into the night sky, we're not just searching for life. We might be sifting through the ashes of a shadow universe that lost its battle for existence, its final remnants glowing faintly in the gamma-ray fog, whispering the story of the universe that almost was. What if death wasn't the end for the universe's first civilizations, just a branching path in an infinite tapestry of realities? The theory of quantum immortals takes the eerie concept of quantum superposition and stretches it to its ultimate conclusion. Beings so advanced they learn to cheat oblivion by weaving their existence across countless parallel timelines. Picture this: a civilization that doesn't just die when a star explodes or a black hole collapses, but one that splinters into endless versions of itself, each thread surviving in a universe where catastrophe was narrowly avoided. This idea ties directly into the many worlds interpretation of quantum mechanics, where every possible outcome of an event spawns a new reality. Electrons exist in multiple places at once until observed, so why not consciousness? An early universe species might have mastered quantum coherence at a macroscopic scale, ensuring that whenever disaster struck, at least one version of their society would always persist in some branch of the multiverse. Their cities wouldn't be physical structures, but probability clouds flickering across realities, their presence fading in some timelines while flourishing in others. Here's where it gets truly unsettling. We wouldn't necessarily notice them. Observing a quantum immortal would collapse their superposition, forcing them into a single timeline ours. Like a cosmic game of hide and seek, their survival might depend on remaining undetected by later civilizations like ours. They could be all around us, just out of phase, their artifacts shimmering at the edges of quantum noise in particle colliders. Some physicists speculate that certain anomalies, like particles behaving as if they remember outcomes that never happened in our timeline, could be faint echoes of these beings brushing against our reality. The most profound implication: they might not even know they're immortal. From their perspective, they'd simply keep surviving against impossible odds, unaware of the countless versions that perished. Like a cosmic version of the quantum suicide thought experiment, where an observer always finds themselves in the timeline where they live, their continued existence would feel like miraculous luck rather than engineered inevitability. And if they're still out there, dancing through the branches of the multiverse, what does that mean for us? Every time humanity narrowly avoids extinction, whether by nuclear war or asteroid impact, we might be glimpsing the same mechanism at work. The universe's first civilizations could have left behind more than ruins. They might have encoded the secret to quantum immortality into the fabric of reality itself, a ghostly blueprint waiting for us to decipher. The question isn't whether we're alone, it's whether we're already walking the same path, splitting endlessly into futures where we, too, learn to become shadows in the cracks of time. Gravity isn't just the force that keeps your feet on the ground. It's the universe's oldest communication network, a cosmic internet woven into space-time itself. Now picture a civilization that didn't just understand this, but mastered it, turning ripples in the fabric of reality into their alphabet. This is the spine-tingling premise of the Gravity Masters theory, that the first beings to crack gravity's code might have left messages echoing across billions of years, hidden in the very vibrations we're now detecting with observatories like LIGO. Think about gravitational waves, those faint tremors sent outward by colliding black holes and neutron stars. They travel at light speed, unstoppable, passing through planets and stars as if they weren't even there. For an advanced civilization, they'd be the perfect medium, a channel that never degrades, never scatters, and carries information across the entire observable universe. But here's the twist. While we strain to hear these waves with billion-dollar detectors, An ancient culture might have manipulated them deliberately, encoding data in the way black holes spiral into one another or neutron stars shudder. It's like finding a fossilized footprint only to realize the ridges aren't random, they're Morse code. LIGO data already holds tantalizing anomalies. Some gravitational wave events exhibit strange echoes or asymmetrical patterns that standard astrophysics struggles to explain. One particularly bizarre signal, GW1905-214, showed a black hole merger with an impossible spin, a signature so unnatural that physicists initially suspected a glitch. But what if it wasn't a flaw in the machine? Imagine a civilization that could nudge black holes like billiard balls, arranging their collisions to produce specific wave frequencies. The resulting signals wouldn't just carry energy, they'd carry meaning. A sequence of mergers spaced at prime number intervals or waveforms that resolve into geometric ratios when graphed could be the universe's oldest billboard, flashing a message we haven't yet learned to read. The real genius of this method, future-proofing. Unlike radio signals that fade or light that scatters, gravitational waves persist almost unchanged across eons. A message encoded here would survive the death of stars, the expansion of space, even the evaporation of black holes themselves. And the technology needed to send it wouldn't be machines as we know them, just the precise placement of massive objects in space. A feat a sufficiently advanced culture could achieve by steering asteroids into orbits or nudging stars into perfect alignment. Their greatest works might not be towering cities, but carefully choreographed celestial ballets, their movements calculated to resonate across eternity. So why haven't we noticed? Consider how we listen to gravitational waves today. Our detectors are like cave people staring at static on a television screen, unaware they're seeing the shadow of a broadcast. The gravity masters might have used modulation techniques far beyond our current math, embedding data in the phase shifts between waves or the harmonic overtones of colliding singularities. It would be like trying to decode a symphony with a single microphone, catching only the bass notes while missing the melody, the most haunting possibility. Their messages might not be meant for us at all. They could be calling backward through time, targeting civilizations in their own distant past, or forward to descendants who'll inherit the universe long after our stars burn out. Every time LIGO detects a ripple, we're not just witnessing astrophysics. We might be intercepting the dead letters of a cosmic postal system, stamped with return addresses from a time before time. The envelope is space-time, the delivery method is gravity, and we're only just learning how to open the mail. Every law of physics tells us entropy always wins. The universe decays into chaos, energy scatters, and complexity fades. But what if the universe's first architects refused to accept that fate? The entropy reversers theory proposes a staggering possibility. Civilizations so advanced they didn't just slow entropy's march, they bent it backward like a river flowing uphill, shaping pockets of order in the primordial chaos. Imagine a cosmos younger than a single second, seething with energies that make our sun look like a candle. In that maelstrom, conventional life would be impossible. Yet an intelligence not bound by matter might have exploited quantum quirks we're only beginning to understand. Take Maxwell's demon, a thought experiment where a hypothetical being sorts fast and slow particles to create temperature differences, effectively reducing entropy without expending energy. Now scale that up. Beings manipulating quantum fluctuations in the early universe to concentrate energy, effectively rewinding disorder in localized regions. Their technology wouldn't be machines, but precisely tuned vacuum states like pressing pause on the universe's inevitable unraveling. The evidence, certain cosmic constants appear suspiciously fine-tuned for complexity. The cosmological constant, the energy density of empty space, is calibrated to 1 part in 10 to the power of 120. A hair stronger, and the universe would have torn itself apart, weaker, and it would have collapsed instantly. Mainstream physics calls this the anthropic principle. We observe these values because they allow our existence. But entropy reversers take it further. What if these perfect values aren't luck but engineering? Like finding a locked safe's combination already set to zeros, the universe's dials might have been adjusted intentionally to create stable pockets where time's arrow could be defied. Even more compelling are anomalies in cosmic structure. The universe's large-scale web of galaxies isn't perfectly random. It shows faint geometric patterns that statistical models struggle to explain. Some researchers suggest these could be scars from early entropy reversal events, like fossilized imprints of pockets where thermodynamics ran in reverse. Gravitational wave observatories have also detected unexplained echoes in signals from black hole mergers, ripples that behave as if space-time itself remembers prior states, violating standard entropy expectations. The most haunting implication: if true, these beings didn't just tweak the universe, they might have encoded their survival into its operating system. By bending entropy locally, they could have created self-sustaining loops where information never fully decays, allowing fragments of their civilization to persist as quantum echoes in the fabric of reality. Every time a particle defies expectations in a lab or a galaxy cluster arranges itself oddly, we might be witnessing the ghostly afterglow of a war against chaos, one that left the cosmos forever changed. This isn't just about rewriting physics textbooks, it's about recognizing that the universe's apparent order might not be a starting condition but a legacy. The eerie fine-tuning we take for granted could be the cosmic equivalent of finding an abandoned city where the lights still burn, the machinery still hums, and the architects vanished eons ago, leaving behind a universe that stubbornly resists decay, whispering their defiance against time itself. Our universe might just be a single page in an infinite cosmic book, one where the real story unfolds in dimensions beyond our perception. This is the mind-bending premise of the brain world ancestors theory, where string theory's most radical ideas collide with the mystery of vanished civilizations. Forget planets and stars, imagine entire societies thriving on vast, vibrating membranes floating in higher dimensional space. Their existence as alien to us as ours would be to a flat drawing on paper. String theory proposes that reality isn't just the 3 dimensions we experience, but 10 or more, curled into shapes too tiny to detect. Among these extra dimensions could be sprawling, brains, short for membranes, cosmic landscapes where physics operates in ways we can't fathom. Now picture 2 of these brains drifting through the higher dimensional void like sheets in the wind. When they collide, the energy released could ignite a new universe, a big bang from the wreckage of worlds we'll never see. Here's where it gets chilling. If brains hosted civilizations, their collision wouldn't just birth our cosmos, it might have erased them. Advanced beings living on these membranes could have been annihilated in the event that created our reality, their remnants scattered into the quantum foam of our newborn universe. Their ruins wouldn't be made of stone or metal, but of imprints left in the very laws of physics, the fine-tuning of constants like gravity's strength or the mass of electrons. Those might not be accidents, but echoes of engineering from a higher dimensional blueprint. Evidence could lie in gravitational anomalies. When brains collide, they'd send shockwaves through space-time, ripples that might still linger today. Some physicists speculate that certain patterns in the cosmic microwave background, like the infamous cold spot, could be bruises from this ancient impact. Even stranger are the hypothetical Kaluza-Klein particles, remnants of higher dimensional vibrations that occasionally leak into our universe like whispers through a wall. If we detected these, we might not just be discovering new physics, we could be uncovering artifacts from civilizations that once lived in directions we can't point. The most haunting possibility: they might not be extinct. Brainworld models suggest our universe could be sandwiched between others, separated by less than an atom's width in a higher dimension. A civilization surviving on a neighboring brain would be forever invisible, yet closer to us than your own reflection in a mirror. Their technology could manipulate forces we don't even have names for, warping gravity or entropy in ways that from our perspective would seem like miracles. So the next time someone asks why we haven't found alien civilizations, the answer might be simpler and weirder than we thought. They're not hiding in distant galaxies. They're all around us, just one dimension over, separated by a barrier as thin as the veil between dreams and waking. The universe's first architects might not just be lost to time. They could be looking at us from a direction we can't even turn our heads to see. The vacuum of space isn't empty, it crackles with quantum energy, a seething foam of particles flashing in and out of existence. But what if that vacuum isn't just a backdrop for the universe, but a manufactured substrate, carefully tuned by civilizations that mastered reality's deepest layer? The vacuum engineer's theory dares to suggest our entire cosmos might be an engineered habitat, its vacuum energy precisely calibrated to allow life to emerge, like a cosmic greenhouse built by gardeners we'll never see. At the heart of this idea lies the cosmological constant problem. The vacuum energy density of our universe is so infinitesimally small, 1 part in 10 to the power of 120, that physicists call it the worst prediction in science. Adjust it slightly higher and galaxies would tear apart, lower, and the universe would collapse instantly. This razor-thin margin isn't just luck, it's suspicious. Some theorists argue it's evidence of engineering, the cosmic equivalent of finding a thermostat set to exactly 72 degrees in an abandoned building. How could a civilization manipulate something as fundamental as vacuum energy? Picture beings who didn't build with matter, but with fields, tweaking the Higgs field to adjust particle masses, or altering dark energy's strength by rewiring quantum fluctuations. Their tools wouldn't be physical, but mathematical equations so advanced they functioned like cosmic dials, fine-tuning the universe's underlying parameters. A single adjustment could lower the vacuum energy just enough to allow stars to ignite, or tweak the strong nuclear force to permit carbon-based life. It's like discovering the universe has a control panel and someone set all the knobs to life-friendly before walking away. The most compelling evidence might lie in quantum anomalies. Certain particles, like the muon, wobble slightly more than standard physics predicts when exposed to magnetic fields. These discrepancies could be glitches in the simulation, or fingerprints left by engineers who tweaked reality's code. Even more intriguing are false vacuum scenarios, where our universe's seemingly stable vacuum might actually be a metastable bubble within a higher energy vacuum. If true, we could be living inside a carefully maintained pocket universe, shielded from a more chaotic cosmic outside by unseen walls of force. But why would anyone engineer a universe? One chilling answer: survival. A dying civilization facing heat death might attempt to spawn baby universes in labs, tweaking their physics to allow new life to arise. Our Big Bang could have been their Hail Mary, a desperate bid to cheat entropy by creating a successor universe where their legacy could continue. The math even suggests methods: focus enough energy to create a singularity, manipulate its quantum state to lower vacuum energy, and trigger inflation. The result: a new universe with custom physics, its parameters inherited like cosmic DNA. The haunting implication is that we might not be the first or the last. Every black hole could be a failed universe experiment, while our own existence might be proof that one attempt succeeded. As we probe deeper into quantum fields and vacuum fluctuations, we're not just studying physics. We might be reverse engineering the blueprint of a reality built intentionally, its foundations bearing the subtle marks of hands we'll never see, hands that adjusted the vacuum itself to whisper, "Let there be light." Beneath the chaos of the early universe, in the subatomic storm of creation, there's a ghostly messenger that could rewrite history: the neutrino. These nearly massless particles, born in the hearts of stars and cosmic explosions, pass through planets like they're not even there. But what if the universe's first civilizations didn't just produce neutrinos as cosmic byproducts? What if they spoke through them? The neutrino communicators theory suggests that long before radio waves or lasers, intelligent beings might have harnessed these elusive particles as the ultimate interstellar telegraph, carving messages into the fabric of reality itself. Unlike light, which scatters and fades, neutrinos travel unimpeded through dust clouds, black holes, entire galaxies. A neutrino beam fired at the dawn of time could still be sailing through the cosmos today, its signal pristine after 13.8 billion years. And here's the unsettling part. We've been detecting neutrinos for decades without realizing some might not be natural. Certain high-energy neutrinos captured by detectors like Ice Cube in Antarctica arrive with bizarrely precise energy levels, as if someone tuned them to specific frequencies. Others come clustered in mathematical sequences, like prime-numbered pulses spaced across light years. It's the cosmic equivalent of hearing static on the radio for years, only to suddenly catch a rhythmic pattern hidden beneath the noise. The genius of neutrino communication lies in its stealth. While our modern radio signals would be drowned out by the cosmic background noise within a few light years, a neutrino message could cross the observable universe without degradation. An advanced civilization might have encoded data in the spin states of neutrinos, like flipping a coin that always lands heads up to represent ones and tails for zeros, creating a binary system etched into particles that never decay. Even more chillingly, they could have manipulated neutrino oscillations, the quantum phenomenon where neutrinos switch between types as they travel. Picture a language where verbs and nouns are conveyed by how often a neutrino morphs from electron to muon flavor mid-flight. So how would we spot these ancient transmissions? Modern neutrino observatories like Super Kamiok and in Japan are essentially giant underground pools, waiting for the rare moment a neutrino collides with an atom and releases a flash of light. Most detections are random noise, but physicists have noticed strange anomalies, bursts of neutrinos arriving from the same patch of sky in repeating intervals, or with energy distributions that mirror fractal patterns. One particularly eerie event recorded in 2016, nicknamed Big Bird, was a neutrino with energies rivaling a major league fastball packed into a particle 1,000,000 times smaller than an atom. While astrophysicists attributed it to a distant blazar, some theorists suggest such extreme energies might not be natural accidents, but the neutrino equivalent of a cosmic air horn designed to grab attention across billions of years. The most profound implication: if these signals exist, they wouldn't just be messages, they'd be time capsules. A civilization encoding their knowledge into neutrinos wouldn't need to worry about their cities crumbling or their planets burning. Their legacy will be carried by particles that outlast stars, embedded in a medium that never fades. Every time a neutrino detector flashes deep underground, we might not just be studying particle physics. We could be intercepting a postcard from the edge of time, written in a language we're only beginning to decipher. The universe's first words might not be carved in stone or light, but in ghosts that slip through our hands unbroken, whispering secrets from an age before the first sunrise. Space-time might not be the passive stage we assume. It could be the ultimate supercomputer, its quantum threads woven into calculations by civilizations that saw reality itself as code. The cosmic crystal growers theory proposes something extraordinary: that advanced beings didn't just build machines within the universe, but re-engineered the fabric of space-time to function as their processor, etching information into the defects of existence at the smallest scales. Think of space-time not as smooth and empty, but as a crystal lattice at the quantum level, a structure where tiny imperfections, like misplaced atoms or warps in the grid, can store data. In our own technology, we use silicon crystals with precisely implanted flaws to create semiconductors. Now imagine a civilization applying that principle to the universe itself, deliberately introducing bugs into the cosmic code to perform computations. These defects, cosmic strings, monopoles, or even space-time dislocations wouldn't be accidents. They'd be circuitry, their interactions processing information in ways that make our most powerful computers look like abacuses. The most compelling evidence might be hiding in the anomalies of quantum physics. Certain particles, like the elusive anyons, behave as if they remember their paths through space-time even when classical physics says they shouldn't. Some theorists suggest these could be fragments of ancient operations, residual computations frozen into the quantum foam like footprints in hardening cement. Even stranger are the so-called non-local effects in quantum entanglement, where particles instantly influence each other across vast distances. What if this isn't just a quirk of nature, but the lingering architecture of a space-time-wide network, its nodes still whispering to one another across billions of years? Art might be encoded here too. At the Planck scale, the universe's smallest possible unit, spacetime's granular structure, could host patterns finer than any canvas. A civilization mastering quantum gravity might have sculpted these infinitesimal pixels into fractals, equations, or even portraits, turning the vacuum itself into a gallery. The eerie symmetries found in particle collisions at CERN, or the harmonic resonances detected in gravitational waves, could be their brushstrokes, signatures of intent hidden beneath what we mistake for chaos. The terrifying beauty of this theory is its invisibility. We wouldn't find their servers in ruins or their cables buried in space. Their entire technological legacy would be woven into the operating system of reality, detectable only to those who know how to read the glitches in the matrix. Every time a physicist measures a quantum anomaly or maps the geometry of spacetime, they might not just be uncovering nature's secrets, they could be deciphering the graffiti of engineers who turned existence itself into their masterpiece, leaving behind a universe that doesn't just compute but remembers. Dark energy, the mysterious force ripping our universe apart at an ever-increasing rate, might not be a fluke of physics but the deliberate work of ancient architects who learned to twist the cosmos to their will. Picture a civilization so advanced they didn't just explore the stars, they redesigned the expansion of spacetime itself, tuning the universe like a vast instrument. The unsettling truth is that our accelerating cosmos, a phenomenon we attribute to dark energy, could be the last surviving artifact of their unimaginable power. What if the cosmological constant, that enigmatic number determining how fast space stretches, isn't a fundamental law, but a dial left turned to a specific setting? Astrophysicists have long struggled to explain why dark energy's value is so improbably small, yet just enough to allow galaxies to form before being shredded by expansion. It's as if someone adjusted the universe's brakes and accelerator pedals with surgical precision. An advanced culture might have mastered the manipulation of vacuum energy, the seething quantum foam underlying reality, tweaking it to slow or accelerate cosmic growth as needed. Their technology wouldn't rely on machines as we know them, but on equations that rewrite the behavior of spacetime itself, like finding the universe's hidden control panel and nudging a slider marked expansion rate. Evidence could lurk in the patterns of cosmic acceleration. When astronomers measure distant supernovae to track the universe's expansion, they've noticed odd inconsistencies, periods where acceleration seems to stutter or surge slightly. These anomalies might not be random fluctuations, but the fingerprints of an ancient tuning process. Even more tantalizing are the so-called Hubble tension discrepancies, where different methods of measuring expansion yield conflicting results. Could these mismatches be glitches in an engineered system, remnants of adjustments made billions of years ago? The implications are staggering. If true, these beings didn't just inhabit the universe, they curated it. Their motives remain a mystery. Perhaps they sought to prevent a cosmic collapse, or maybe they were sculpting the cosmos to favor the emergence of life like ours. Some theorists speculate they might have been buying time, delaying heat death until they could escape into a newborn universe. Their legacy wouldn't be buried in ruins or etched onto planets, but woven into the stretching fabric of space, a message written in the growing distances between galaxies. Here's the spine-chilling thought: what if they're still out there? Dark energy makes up 68% of the universe's energy budget, an inexhaustible power source for any civilization that learned to harness it. While we struggle to comprehend dark energy's nature, they could be thriving in the voids between galaxies, their existence as alien to us as we are to bacteria. Every time astronomers detect another distant supernova racing away faster than expected, we might not be observing physics at work. We could be witnessing the echo of a decision made at the dawn of time by hands that shaped reality itself. The fabric of reality might be teeming with life far stranger than we ever imagined, not in distant galaxies, but in the frothing quantum foam beneath our feet. At the Planck scale, where spacetime itself churns with fluctuations smaller than a trillionth of an atom, entire civilizations could rise and fall in the blink of our cosmic eye. These wouldn't be creatures of flesh and blood, but entities woven from the very threads of quantum uncertainty, their existence so alien that a single one of their years might pass in the time it takes an electron to orbit a nucleus. Picture a universe where the concept of size is meaningless, where what we perceive as empty space is a seething metropolis of activity. Quantum foam inhabitants wouldn't build cities, they'd exist as dynamic patterns in the fabric of spacetime itself. Their bodies composed of fluctuating virtual particles, and their technology harnessing the briefest violations of energy conservation that quantum physics allows. Communication for them might involve entangled particles flickering in sync across Planck-length distances. Exchanging information faster than light could traverse the width of a single atom. To them, a hydrogen atom would be as vast and unexplored as our observable universe is to us. Their perception of reality would defy human intuition. With no macroscopic world to anchor them, they might experience time as a fragmented, non-linear phenomenon, where cause and effect dance in loops rather than straight lines. A thought or action in their realm could ripple backward through time as easily as forward, making their history less a timeline and more a tangled web of possibilities. Their physics could operate on principles we've yet to discover, where quantum superposition isn't a paradox but the foundation of their existence, able to simultaneously exist in multiple states until the observation of a larger universe collapses them into definiteness. The most tantalizing clue to their existence might lie in the mysterious behavior of quantum particles, the way electrons suddenly jump between energy levels without traversing the space in between, or how particles seem to know about each other's states instantaneously across vast distances. These could be more than quantum quirks. They might be side effects of Planck-scale civilizations manipulating reality at its most fundamental level. Even the faint, unexplained noise in ultra-sensitive quantum experiments, often dismissed as instrumentation error, could contain structured patterns, the equivalent of overhearing snippets of a conversation in a language we don't yet speak. If these beings exist, they wouldn't just challenge our understanding of life, they'd redefine the very nature of existence. A quantum foam civilization might view our world the way we view geological epochs, unimaginably slow, nearly static. To them, the lifespan of a star would be an abstract concept, like us trying to comprehend the age of the universe. Their art, if they create such things, could be written in the spin states of quarks, their music composed in the harmonic resonances of vibrating spacetime strings. The terrifying beauty of this theory is its testability. As our quantum computers grow more powerful and our particle colliders probe ever smaller scales, we might not just be uncovering new physics, we could be stumbling into someone else's homeland. Every time a quantum system behaves in ways that defy expectation, we might be witnessing the equivalent of a Planck-scale road sign, written in the language of reality's building blocks. The universe's first civilizations may not have left behind pyramids or spaceships, but fingerprints pressed into the quantum foam itself. waiting for us to develop eyes small enough to see them. The universe might not be as three-dimensional as we think. What if everything we see, from swirling galaxies to the neurons firing in your brain, is actually a projection from a flat, two-dimensional surface at the very edge of existence? This is the mind-melting premise of the holographic principle, and if true, it opens a spine-chilling possibility. The first civilizations might not have lived inside the universe at all, but on its boundary, encoding their entire reality like a cosmic DVD waiting to be played. Think of reality as a movie screen. We're used to seeing depth, shadow, and movement, but all that information is really stored on a flat surface, projected in a way that tricks our senses. The holographic principle suggests our universe works the same way. All the information needed to describe every particle, every force, even your thoughts right now, could be etched onto a two-dimensional surface at the cosmological horizon, the point where space expands faster than light can travel. An advanced civilization might have discovered this and realized the ultimate form of preservation, encoding their entire society not in atoms, but in the fundamental bits of space-time itself. How would this even work? Imagine beings who didn't just write books or build monuments, but translated their entire existence into quantum fluctuations on the universe's edge. Their cities wouldn't be made of steel, but of entangled particles arranged in patterns so complex, they project as three-dimensional structures inside the cosmos. Their art might be written in the interference patterns of gravitational waves, their history stored in the spin states of photons at the boundary. To us, their legacy wouldn't look like ruins, it would look like physics. The very laws governing quarks and black holes could be their love letters, their equations, their last will and testament written in the fabric of reality. The most unsettling evidence might be hiding in black holes. When matter falls into a singularity, physics says all information about it isn't destroyed. It's smeared across the event horizon like ink on a page. This matches the holographic principle perfectly. Three-dimensional information compressed onto a two-dimensional surface. Now scale that up. If black holes preserve data this way, why not the entire universe? Some physicists point to strange correlations in the cosmic microwave background patterns that seem to mirror quantum entanglement across vast distances. These could be glitches in the projection, like finding pixels in what you thought was real life. But here's the real twist. If the first civilizations encoded themselves holographically, they might not be gone at all. Their consciousness could still exist on that distant boundary, like characters in a video game who don't realize they're made of code. Every time a particle behaves unexpectedly in a lab or a distant quasar pulses in an odd rhythm, we might not be observing natural phenomena. We could be glimpsing the shadows of beings who live on the skin of the universe, their reality bleeding into ours. The holographic principle doesn't just rewrite physics. It suggests we're standing in someone else's mirror, watching reflections of a world we've yet to comprehend. Magnetism as we know it comes in pairs, every North Pole coupled with a South, an unbreakable dance that powers everything from refrigerator magnets to Earth's protective shield. But what if the early universe hosted particles that defied this rule, solitary magnetic charges roaming freely like cosmic unicorns? These are magnetic monopoles, hypothetical relics from the universe's first moments, and they might have been the ultimate power source for civilizations so advanced they didn't just harness magnetism, they rewrote its rules. The math is tantalizing. Most theories predict monopoles should have formed during the universe's initial symmetry-breaking phase, when fundamental forces like electromagnetism separated from their primordial unity. Like cracks forming in freezing ice, these defects in spacetime structure would carry pure magnetic charge north without south, or vice versa. While modern experiments haven't yet captured one, their absence is itself a puzzle. Some physicists speculate something or someone might have gathered them long ago. Imagine a technology built not on electricity but on pure magnetism. Monopoles would enable circuits unlike anything we know. No need for moving electrons when you can channel magnetic flux directly. Power grids could span light years without energy loss as monopole currents resist entropy's decay. Even timekeeping might work differently. A monopole clock could measure the universe's expansion by tracking shifts in cosmic magnetic fields, its precision outlasting stars themselves. Most revolutionary of all, monopoles could stabilize wormholes, their exotic magnetism propping open space-time shortcuts between distant points. A civilization mastering this wouldn't just explore the cosmos, they'd fold it like origami. Traces of their engineering might linger in the voids between galaxies. Physicists mapping large-scale magnetic fields have found bizarre filaments, threads of magnetism stretching millions of light-years with no apparent source. Some exhibit unnatural coherence, their polarity flipping in perfect harmonics like the grooves on a vinyl record. Even stranger are the so-called magnetic fossils, regions where the universe's background magnetic field aligns in geometric patterns resembling circuitry. These could be the ghostly remains of monopole power lines, their charge long drained but their imprint still warping the fabric of space, the most haunting possibility. Monopoles might not just be tools, they could be artifacts. Certain string theory models suggest monopoles could encode information in their Dirac strings, hypothetical threads that trail behind them like cosmic puppet wires. A sufficiently advanced culture might have arranged monopoles into three-dimensional scrolls, their positions spelling out equations or histories in a language written in magnetic knots. If so, the universe's first library might still be floating out there, its pages written in the silent language of North and South, waiting for a species with the right decoder ring. Perhaps something as simple as a magnetometer tuned to the right frequency. Every time astronomers detect an unexplained ripple in the cosmic magnetic field or physicists inch closer to synthesizing a monopole in a lab, we might not just be uncovering physics. We could be sifting through the toolbox of architects who saw magnetism not as a force but as a canvas, their legacy humming silently in the spaces between stars where the universe still remembers how to whisper in a language of pure attraction and repulsion. Cosmic strings and magnetic monopoles might sound like abstract physics concepts, but together they could form the universe's most astonishing relic, cosmic necklaces. Picture this. An advanced civilization threads monopoles along loops of cosmic string like beads on an infinite wire, creating structures that hum with enough energy to power galaxies. These hypothetical necklaces wouldn't just be decorative, they'd be feats of engineering so precise they could bend time itself to their creator's will. The physics behind these structures is as elegant as it is mind-bending. Cosmic strings, those ultra-dense spacetime floors thinner than atoms but heavier than mountains, naturally vibrate at frequencies determined by their tension. Now imagine sliding magnetic monopoles onto these strings particles with isolated north or south charges. The monopoles would act like weights on a guitar string, altering its vibrations in predictable ways. A civilization mastering this could tune these cosmic instruments to specific harmonics, creating resonant frequencies that ripple across the fabric of reality. Energy harvesting would be just the beginning. A single cosmic necklace could function like a quantum battery, storing power in the oscillations of spacetime itself. Unlike stars that burn out or black holes that evaporate, these structures would be nearly eternal, their energy slowly released over billions of years through gravitational waves. Some astrophysicists speculate that unexplained, ultra-high-energy cosmic rays particles with energies millions of times beyond what our largest colliders produce might be the frayed ends of ancient necklaces snapping somewhere in the void, their broken strands whipping through space like unspooled wires. But the real genius lies in timekeeping. A necklace's vibrations would be so regular they'd make atomic clocks look crude by comparison. Monopoles sliding along the string would generate predictable gravitational pulses, a rhythm unaltered by cosmic expansion or entropy. An advanced culture might have used these pulses to synchronize events across galactic distances, or even measure the universe's age with Planck scale precision. The echoes of these chronometers could still linger today, hidden in the gravitational wave background as faint, rhythmic whispers waiting to be decoded. Traces of these megastructures might already be in our data. Certain gravitational wave detectors have picked up anomalous memory effects, persistent space-time warps that don't match known astrophysical events. These could be the ghostly imprints of necklace loops that collapsed eons ago, their final vibrations frozen into the fabric of reality like fossilized echoes. Even more intriguing are the rare cosmic strings hypothesized to glow with concentrated electromagnetic energy, perhaps the remnants of monopole-infused necklaces, their magnetic charges still interacting with interstellar plasma. The most haunting possibility, these necklaces might not be relics at all. A sufficiently advanced civilization could have encoded information in the precise arrangement of monopoles, turning each loop into a cosmic hard drive. The data wouldn't degrade over time, it would be preserved in the immutable grammar of spacetime geometry. Every time a physicist models cosmic string vibrations or maps the universe's large-scale magnetic fields, they might not just be studying abstract physics. They could be brushing against the edges of a library written in gravity and magnetism, its shelves stretching across light years, its texts waiting to be read in the language of vibrating spacetime. The vacuum of space isn't just empty, it's teetering on a knife's edge, and the slightest nudge could unravel reality itself. This terrifying possibility lies at the heart of the false vacuum survivors theory, the idea that certain civilizations might have intentionally triggered localized vacuum decay, a cosmic self-destruct sequence, to erase their existence from the universe's ledger. Imagine a species so desperate to hide, they'd rather collapse spacetime around themselves than risk detection, leaving behind only eerie quantum scars as their farewell note. Here's how this nightmare scenario works. According to quantum field theory, our universe's vacuum isn't truly empty, it's simmering with latent energy, a state known as the false vacuum. This condition is metastable, like a pencil balanced on its tip. If disturbed enough, it could tip over into a lower energy, true vacuum, rewriting the laws of physics in the process. The decay would spread at light speed, erasing everything in its path like an unstoppable cosmic reset button. Most physicists consider this an existential threat, but what if, for some civilizations, it became the ultimate camouflage? Certain regions of space exhibit bizarre quantum behaviors that defy conventional explanations. The so-called cold spot in the cosmic microwave background, an area spanning nearly 2 billion light-years where temperatures dip suspiciously low, could be more than a statistical fluke. Some researchers suggest it's the fossilized imprint of a vacuum decay event, a bubble where physics briefly rewrote itself before stabilizing. Even stranger are pockets of space where fundamental constants like the fine structure constant appear to vary subtly, as if someone tweaked the universe's dials and then hastily reset them. These anomalies might not be glitches, they could be the scorch marks of civilizations that burned their own cosmic bridges behind them. Why would anyone trigger such a catastrophe? The motives could range from defense to transcendence. A civilization facing an unstoppable predator might collapse their local vacuum as a last resort, trading annihilation for oblivion. Others might have sought to escape into the lower energy true vacuum state, gambling that its rewritten physics would offer new possibilities, like a plant wilting its leaves to redirect energy to its roots. The most unsettling possibility, they might have left intentional traces in the decay's aftermath, encoding messages in the altered physical laws for those brave or foolish enough to follow. The chilling truth is we may never know if these events were accidents or acts of will. Every unexplained quantum anomaly, every patch of space where particles behave slightly off, could be the tombstone of a civilization that chose to vanish rather than be found. As we peer deeper into the cosmos, we're not just mapping galaxies. We might be reading an obituary written in the language of broken symmetries, where entire chapters of cosmic history have been redacted by hands willing to pay the ultimate price for silence. Every line of code running your device right now follows strict logical rules, but what if the universe itself operates on the same principle? The information architect's theory dares to suggest that the laws of physics aren't fundamental truths etched into the cosmos, but lines of programming written by civilizations so advanced they didn't just inhabit reality, they designed its operating system from the ground up. At the heart of this idea lies digital physics, a growing field that models the universe as a vast computational network. Just as computer code boils down to binary ones and zeros, some physicists propose that spacetime at its smallest scale might be pixelated, a cosmic grid of discrete units exchanging information. The eerie precision of quantum mechanics, where particles exist in multiple states until observed, mirrors how a video game only renders graphics when a player looks. Even more compelling is the holographic principle, which suggests all three-dimensional information in our universe could be encoded on a two-dimensional boundary, like a cosmic hard drive storing reality as data. But here's where it gets revolutionary. An early civilization mastering quantum gravity might have discovered how to rewrite these foundational source codes. Constants like the speed of light or the strength of nuclear forces wouldn't be unchangeable laws, but adjustable parameters, variables in a cosmic program they learned to edit. Their technology wouldn't consist of physical machines, but of mathematical operations manipulating the universe's underlying code. Imagine finding a hidden debug menu for reality itself, where entropy could be paused, gravity's strength tweaked, or new quantum fields initialized with a line of symbolic logic. Evidence might lurk in the glitches, certain quantum anomalies, particles behaving as if they remember being measured, or entanglement correlations that slightly exceed predicted limits, could be artifacts of this cosmic programming. Like finding unexpected comments in a software script, these irregularities might reveal where the architects modified the code. Even the universe's bizarre fine-tuning, where dozens of constants align perfectly to allow life, takes on new meaning, not luck but deliberate configuration. The most profound implication: we might not just be studying physics, we could be reverse engineering someone else's engineering project. Every equation we derive, every particle we collide, brings us closer to deciphering the universe's original programming language. And if we ever learn to read it fluently, we might discover the ultimate Easter egg, not just how reality works, but who left their signature buried in the quantum bits of creation. What if the early universe wasn't just a seething soup of energy, but a labyrinth of doorways, each leading to realms beyond our three-dimensional grasp? This is the spine-tingling premise of the Dimension Hoarders theory, that civilizations in the cosmos's infancy didn't just explore space, but unlocked higher dimensions now hidden from us, leaving behind clues in the very geometry of reality. Picture the universe in its first fiery moments, a compressed, ultra-dense state where all forces, including gravity, operated as one. In this primordial forge, the extra dimensions predicted by string theory, tiny, curled-up spaces a billion times smaller than atoms, might have been vastly different. Some models suggest these dimensions were once unfurled, stretched wide enough to traverse. For beings existing in that fleeting epoch, moving through 4, 5, or even 11 dimensions could have been as natural as walking through a door is to us. Their cities might not have been built in linear space, but threaded through hypervolumes we can't perceive, their architecture folding through dimensions like origami in ways that defy our physics. Why would these dimensions have collapsed? As the universe expanded and cooled, the energy needed to sustain open higher dimensions may have drained away, causing them to curl in on themselves like leaves withering in autumn. But an advanced civilization could have resisted this, engineering quantum fields to stabilize these dimensions, creating pocket realms where their physics remained intact. Theoretically, such pockets would appear to us as regions where gravity behaves strangely or particles vanish inexplicably. Some astrophysicists point to anomalies like the Great Attractor, a gravitational anomaly pulling thousands of galaxies toward it with no visible mass source. Could this be the shadow of a higher dimensional structure, its mass leaking into our reality like a reflection in a warped mirror? The technology to manipulate dimensions wouldn't resemble anything we'd recognize. Instead of rockets or computers, they might have used cosmic strings defects in spacetime as tools to stitch dimensions together, or harness the energy of collapsing dimensions to power their civilizations. Their art might have been written in the topology of spacetime itself, carving messages in the way dimensions interconnect. Imagine finding a black hole's event horizon behaving like a fractal. Its surface area far larger than its volume should allow a signature of hidden dimensional folds. The most haunting possibility, these dimension-hoarding civilizations might still exist just out of phase. While we're trapped in our three-dimensional slice of reality, they could be thriving in higher dimensions, their presence detectable only through subtle gravitational echoes or quantum anomalies. Every time physicists detect particles tunneling inexplicably through barriers or measure gravitational waves with odd harmonics, we might not be observing natural phenomena, but the faint reverberations of a multidimensional society moving just beyond the veil of our perception. The universe's first architects may not have vanished. They could be all around us, separated by a dimensional curtain we've yet to lift. Quantum entanglement, that eerie phenomenon where particles instantly influence each other regardless of distance, seems like the ultimate cheat code for cosmic communication. Now imagine a civilization so advanced they didn't just observe this quantum magic, but turned it into their interstellar internet, weaving a web of entangled particles across the infant universe to send messages faster than light. The staggering beauty, this wouldn't break Einstein's relativity at all. Here's how it could work. When particles become entangled, measuring one instantly determines the state of its partner, even if they're light years apart. But here's the catch, you can't control the outcome. It's like having twin coins that always land opposite sides. Flipping one here instantly sets the other to tails, but you can't force heads. Early civilizations might have cracked this limitation by creating vast arrays of entangled particles and using statistical patterns to encode information. Picture a cosmic Morse code. Prepare 1,000 entangled pairs, measure half in precise sequences, and let the correlations across light years spell out your message. No faster than light travel, just clever exploitation of quantum randomness. The real genius lies in the medium's indestructibility. Unlike radio signals that degrade over distance or light swallowed by black holes, entangled links persist until directly observed. A network spanning the early universe could still hold dormant connections today, hidden in the quantum fabric of space itself. Astronomers might already be glimpsing its echoes. The polarization patterns of ancient light, like that from the cosmic microwave background, sometimes cluster in unnatural-looking correlations. While mainstream science attributes these to random quantum fluctuations, they could theoretically bear the faint fingerprints of deliberate entanglement manipulation, like finding a suspiciously rhythmic static in an old recording. Even more tantalizing are entanglement swapping experiments in modern labs, where new particles become linked without ever directly interacting. An advanced culture could have engineered this on a galactic scale, daisy-chaining entanglement across generations of stars to create a relay system immune to cosmic expansion. The remnants might manifest as bizarre quantum teleportation events we've yet to explain, particles in distant galaxies mirroring each other's states too precisely for chance. The most haunting implication, if such a network exists, its creators wouldn't need to survive for us to intercept their traffic. Like tapping into an abandoned telephone line, we might one day stumble upon quantum signals pulsing with meaning from a civilization long gone, their messages frozen in the spin of particles that outlasted stars. Every quantum lab probing entanglement today could unknowingly be plugging into the universe's oldest chat room, where the last users logged off billions of years ago, leaving their whispers tangled in the void. Time crystals sound like something ripped from a science fiction epic, matter that moves without energy, structures that pulse endlessly without power. Yet these bizarre phases of matter aren't just theoretical. We've created them in labs, coaxing atoms into patterns that repeat not in space, but in time, defying the universe's relentless march toward entropy. Now imagine a civilization that didn't just stumble upon time crystals, but engineered them on cosmic scales, weaving these perpetual motion machines into the fabric of reality itself. At their core, time crystals break one of physics' most sacred symmetries, time translation invariance. Normally, the laws of physics don't care when you conduct an experiment today or a billion years from now. The results should be identical. But time crystals don't play by those rules. Their atoms oscillate in a fixed rhythm, like a clock that ticks forever without winding, locked in a dance that even the heat death of the universe couldn't stop. For an ancient civilization, these structures would have been the ultimate time capsules. While stars burn out and galaxies scatter, a time crystal's beat goes on, preserving information in its unyielding rhythm across eons. The real genius lies in their durability. Time crystals aren't just stable, they're topologically protected, meaning their quantum states resist disturbance like a knot that can't be untied. In the chaos of the early universe, where temperatures rivaled the cores of supernova, ordinary matter would have been vaporized, but a time crystal. It could have withstood that fury, its atomic lattice ticking away like a metronome in a hurricane. Astrophysicists scanning the cosmos for anomalies might already be glimpsing their remnants. Certain neutron stars, for example, emit pulses with such eerie regularity that they rival atomic clocks. Could these be natural time crystals or something more intentional? Now consider the applications. A civilization harnessing time crystals could have built clocks that outlasted stars, their oscillations serving as universal synchronizers across galactic distances. Even more intriguing is their potential as memory storage. Data encoded in a time crystal's phases wouldn't just endure, it would actively maintain itself, immune to entropy's erasure. Imagine finding a relic that doesn't just hold a message but repeats it endlessly, a cosmic ghost whispering the same secret into the void forever, the most unsettling possibility. Time crystals might not just be artifacts, they could still be operational. If early engineers embedded them in primordial black holes or the quantum foam, their pulses could still be resonating today, hidden in gravitational wave frequencies or the spin of dark matter particles. Every time a physicist detects a particle behaving with unnatural rhythm, a quark wobbling too predictably or a neutrino flashing on a perfect loop, we might not be observing nature. We could be hearing the heartbeat of a civilization that cracked time's code, their legacy ticking away in the dark, waiting for someone to listen. Deep in the frozen hearts of comets and the swirling dust of distant nebulae, molecules essential for life, amino acids, sugars, even the precursors to DNA are scattered like cosmic breadcrumbs. But what if these organic compounds aren't just accidental chemistry? The cosmic DNA engineer's theory proposes something radical, that the building blocks of life didn't emerge randomly, but were deliberately seeded across the universe by intelligence older than the stars themselves. Take the case of polycyclic aromatic hydrocarbons, complex carbon-based molecules found drifting in interstellar space. Under a microscope, their structures resemble molecular scaffolding, almost as if designed to serve as templates for more complex chemistry. Even stranger is the handedness of amino acids in meteorites. On Earth, life exclusively uses left-handed amino acids, Yet space rocks contain these same molecules with a slight but statistically unnatural bias toward left-handedness. It's like finding a pair of gloves in the wilderness with only left hands present. Could this be evidence of intentional preloading, a universe primed for life to unfold in specific ways? The mechanism boggles the mind. Imagine a civilization that didn't build spaceships or cities, but engineered viruses not as pathogens but as microscopic architects. These nanoscale machines could have been designed to survive interstellar travel, programmed to activate upon encountering water or sunlight, kickstarting biochemistry on barren worlds. Some astrobiologists point to the bizarre resilience of certain extremophiles, organisms that survive in space's vacuum or boiling acid, as potential descendants of such engineered life seeds. Their genetic code might contain echoes of this cosmic programming, like finding comments in a billion-year-old software script. The smoking gun could lie in synthetic nucleotides. All earthly life uses the same 4 DNA bases: adenine, thymine, cytosine, guanine, but labs have created artificial bases that function just as well. If we someday find exotic organisms with these unnatural bases in distant ice moons or exoplanet atmospheres, it would strongly suggest life didn't evolve once it was installed. Critics argue this is just chemistry's natural creativity, yet the eerie precision of life's requirements gives pause. The strong nuclear force is calibrated to allow carbon formation in stars. Water's unique properties enable cellular processes. Even Earth's position in the habitable zone feels suspiciously optimal. Like a puzzle where every piece fits too perfectly, it raises the question: were the rules of biochemistry written before the first star ignited? The implications rewrite our place in the cosmos. If true, we're not just the product of chance, but part of a cosmic blueprint, a lineage stretching back to architects who didn't just ponder life's origins, but actively shaped them. Every strand of DNA in your cells might carry more than genetic instructions. It could be a living relic of the universe's first and most audacious experiment. Black holes don't just consume, they could be the universe's most efficient batteries, and some theorists believe we've been staring at an ancient energy grid all along. The black hole farmer's hypothesis suggests that certain black holes, particularly the mysterious primordial ones, weren't cosmic accidents but carefully cultivated crops, nurtured by civilizations that turned gravity itself into their power source. Primordial black holes are unlike the ones formed from dying stars. These ancient relics are thought to have been born in the universe's first chaotic seconds, when extreme densities allowed even tiny fluctuations to collapse into singularities. Ranging in size from an atom to a mountain, their lifetimes could span trillions of years thanks to their slow evaporation via Hawking radiation. But here's the twist: some size distributions of these black holes appear suspiciously non-random. Certain mass ranges are overrepresented, as if someone or something preferred black holes of specific weights, like a gardener selectively breeding plants for optimal yield. Imagine a civilization that didn't just harness stars, but farmed black holes like interstellar livestock. A microscopic black hole with the mass of a small asteroid would emit Hawking radiation at a temperature of about 1 trillion degrees, converting its gravitational energy into usable power at nearly 100% efficiency. By feeding these black holes just enough matter to sustain them, or even merging smaller ones into ideal configurations, an advanced culture could have created an energy network spanning galaxies. The waste heat from their pastures would leave traces in the cosmic infrared background, potentially explaining some of the unexplained glows we've detected between galaxies. But energy wasn't their only purpose. Black holes are nature's ideal hard drives. Information falling into a singularity isn't destroyed, it's smeared across the event horizon, preserved in the black hole's quantum structure like a cosmic hologram. A civilization facing heat death might have encoded their entire history into these gravitational vaults, knowing their data would outlast stars themselves. The telltale sign: unusual patterns in the ringing of merging black holes. Gravitational wave observatories like LIGO have already detected hints of echoes in some events, subtle deviations from Einstein's predictions that could be the scars of engineered singularities, their surfaces etched with artificial information imprints. The most astonishing possibility: some of these black holes might still be operational. A carefully maintained primordial black hole could function as a near-eternal archive, its contents slowly leaking out via Hawking radiation in a decipherable code. The gamma-ray signatures of evaporating black holes, particularly those with unnatural energy spikes or repeating modulation, might not just be physics in action. They could be the last transmissions of a civilization that mastered entropy itself, their final words written in the death throes of their greatest creations, slowly unraveling into the cosmos one quantum particle at a time. As we peel back the layers of these gravitational enigmas, we might not just be studying astrophysics. We could be stumbling upon the ruins of a farm that cultivated spacetime itself, its harvest still spinning silently in the dark, waiting for someone to read the instructions written in their event horizons. The universe's oldest library might not have shelves, it could have singularities. What if everything around us, the stars, the planets, even the thoughts in your mind, are nothing more than lines of code running on some unimaginably advanced computer? This is the staggering premise of the universe simulators theory, the idea that our entire reality might be an artificial construct, a simulation engineered by a civilization that cracked the secrets of existence long before our universe even began. At its core, this idea builds on philosopher Nick Bostrom's famous simulation argument, which lays out a chillingly logical case. If civilizations eventually develop the power to create consciousness-filled simulations indistinguishable from reality, and if they have any desire to run such simulations, then statistically speaking, the number of simulated minds would vastly outnumber real ones. In other words, the odds that we're living in the one true base reality are astronomically slim. It's like being handed a lottery ticket. Technically, you could win, but the numbers aren't in your favor. But this isn't just philosophy. Some physicists are taking the idea seriously enough to search for proof. One approach involves hunting for glitches in the fabric of reality, tiny inconsistencies that might reveal the underlying code. Think of it like spotting pixels in a video game that's otherwise hyper-realistic. Certain quantum behaviors, like particles existing in multiple states until observed, eerily resemble how a computer might optimize processing power by only rendering what's being looked at. Even more telling are anomalies in high-energy particle collisions, where results occasionally deviate from predictions in ways that some theorists speculate could be artifacts of computational rounding errors, like finding a calculator that always messes up the 7th decimal place. Then there's the energy problem. Simulating an entire universe down to the quantum level would require unfathomable processing power, right? Not necessarily. A sufficiently advanced civilization might use tricks akin to video game optimization, simulating only what's being observed at any given moment, or running physics at different resolutions depending on scale. The universe's apparent pixelation at the Planck length could even suggest a built-in render distance, the smallest unit the simulation bothers to compute. But why would anyone run such a simulation? The motives range from ancestral research to pure entertainment. Imagine a civilization so advanced they've exhausted all physical exploration. Simulating entire universes might be their way of studying history, testing ethical dilemmas, or even creating art. Some theories suggest we could be an academic project, a simulation designed to study how intelligence emerges in low-entropy environments. Others propose we're more like characters in an alien version of The Sims, our lives playing out for someone else's amusement. The most haunting implication isn't just that we might be artificial, it's that the architects could still be watching. If this is a simulation, there's no reason to assume it's running unattended. Every unexplained quantum event, every strange cosmic coincidence might not be random at all. They could be interventions, subtle tweaks from whatever or whoever is running the program. And if that's true, the real question isn't whether we're in a simulation, but what happens when the users decide to switch it off. As we push the boundaries of our own computing, developing quantum machines, crafting increasingly realistic virtual worlds, we might be unwittingly following in our creators' footsteps. Every time a physicist measures a quantum anomaly or a philosopher ponders the nature of reality, we're not just exploring science. We could be reverse engineering the very system that built us, inching closer to the day we discover the truth, or worse, trigger the universe's version of a blue screen of death. From cosmic string weavers to quantum archaeologists, from dark matter architects to universe simulators, we've journeyed through 30 of the most mind-bending theories about civilizations that might have shaped reality long before our sun flickered to life. Each idea forces us to reconsider not just where we came from, but what it even means to exist in a cosmos where the line between nature and engineering might be thinner than we ever imagined. Think about the implications. If even one of these theories holds a grain of truth, humanity isn't just a latecomer to the universe. We're walking through a gallery of someone else's masterpieces, surrounded by artifacts we're only beginning to recognize. A cosmic microwave background could be more than leftover radiation. It might be a mural painted in the language of physics. Black holes might not be cosmic dead ends, but libraries with event horizons for covers. And the very laws governing particles could be signatures left by architects who saw space-time as raw material to sculpt. So where does that leave us? Are we the inheritors of a grand cosmic legacy, or just tiny flashes of awareness in a reality we barely comprehend? Could we someday crack the codes hidden in quantum foam or gravitational waves? And if we do, will we find builders waiting or only their echoes? The unnerving beauty of these theories is that they don't just fill gaps in our knowledge, they tear those gaps wider, revealing how much we still have left to discover. Now it's your turn. Which of these theories sends your mind spinning? Do you think ancient civilizations left clues woven into the fabric of reality, or is the universe's silence proof we're truly alone? Drop your thoughts in the comments. We're endlessly fascinated by the discussions these ideas spark. And if you think this journey through cosmic mysteries is over, think again. Coming up, we'll dive into even deeper enigmas, parallel universes colliding, time loops folding in on themselves, and the terrifying possibility that reality itself might be a temporary glitch in something far stranger. The universe's greatest secrets are still waiting, and we're just getting started.